Imagine standing just a few kilometers away from the most powerful rocket ever built. It's taller than a 40-story building. It weighs thousands of tons. Its engines roar with enough power to shake the ground beneath your feet. And then, something almost impossible happens. This gigantic machine slowly rises into the sky. A few minutes later, it's traveling faster than a rifle bullet. Soon after, it reaches space. But how can something so unbelievably heavy escape Earth's powerful gravity? Where does all that energy come from? And once it's in space, how does it keep moving without falling back to Earth? Today, we're uncovering one of the greatest engineering achievements in human history. Every time a giant rocket launches, millions of people stop to watch. For a few breathtaking minutes, the impossible becomes reality. A machine weighing thousands of tons climbs into the sky, carrying satellites, astronauts, or even the dream of reaching another planet. But this raises an incredible question. How can something so massive ever leave Earth? Gravity pulls everything downward every second. The heavier an object is, the harder gravity pulls. So how does a giant spacecraft overcome that force? The answer isn't just powerful engines. It's a combination of physics, engineering, chemistry, and decades of innovation. In this episode of Beyond How, we'll follow a giant spacecraft from the launch pad all the way to orbit, discovering how every stage of the journey works. By the end of this video, you'll understand why reaching orbit is one of the most difficult things humans have ever learned to do. Before a spacecraft can explore the Moon, Mars, or distant planets, it must first defeat Earth's gravity. Gravity is always pulling everything toward the center of our planet. Every person, every car, every airplane, and every rocket. Unlike an airplane, a spacecraft cannot rely on wings to create lift. Once it climbs high enough, the atmosphere becomes too thin for wings to work. Instead, rockets must carry everything they need with them. That includes fuel. Lots and lots of fuel. In fact, most of a rocket's weight isn't the spacecraft itself. It's the fuel needed to escape Earth's powerful gravitational pull. A giant rocket can be over 90% fuel before launch. That may sound surprising, but every kilogram of fuel is essential. Without it, the spacecraft would never leave the ground. So how does all that fuel produce enough power to lift thousands of tons? The answer begins with one of the most powerful machines ever created. At the bottom of every giant rocket are engines unlike anything found in airplanes or cars. Instead of simply pushing a vehicle forward, rocket engines must lift the entire spacecraft straight upward. They do this by burning fuel and an oxidizer at extremely high temperatures. The burning fuel creates enormous amounts of hot gas. Those gases are forced through specially designed nozzles at incredible speeds. As the gases shoot downward, the rocket is pushed upward. This follows one of Isaac Newton's most famous ideas. For every action, there's an equal and opposite reaction. The rocket throws exhaust downward. The exhaust pushes the rocket upward. Some modern rockets generate millions of pounds of thrust at liftoff. That's enough force to lift thousands of tons against Earth's gravity. But here's something even more interesting. A rocket doesn't stay heavy for very long. Every second, it burns huge amounts of fuel. As fuel disappears, the rocket becomes lighter. A lighter rocket needs less force to keep accelerating. That simple fact is one of the secrets that makes spaceflight possible. Yet even with incredible engines, the journey has only just begun. Because reaching space is not the same as reaching orbit. And that difference surprises almost everyone. Imagine trying to climb a mountain while carrying a backpack filled with heavy rocks. The higher you climb, the more exhausted you become. Now imagine you could throw away part of that backpack every few minutes. Suddenly, climbing becomes much easier. Rockets work in almost the same way. As they burn fuel, they become lighter. But engineers found an even smarter solution. Instead of carrying empty fuel tanks all the way to space, they simply leave them behind. These are called rocket stages. Each stage has its own engines and fuel. The first stage does the hardest job. It lifts the enormous rocket off the ground and pushes it through the thickest part of Earth's atmosphere. Within just a few minutes, nearly all of its fuel is gone. At that point, it has become nothing more than extra weight. So the spacecraft releases it. The empty stage separates and begins falling back toward Earth. Meanwhile, the second stage ignites almost instantly. Now the rocket is much lighter. With less weight to carry, the engines become far more efficient. Some rockets even have a third stage for missions that travel beyond Earth's orbit. Without staging, carrying enough fuel to reach orbit would be nearly impossible. It's one of the cleverest engineering ideas ever invented. Today, companies like SpaceX are taking this concept even further by designing first-stage boosters that return to Earth and land safely so they can be used again. What once seemed impossible has become routine. But even after all of this, the spacecraft still hasn't truly reached orbit. And here's the surprising part. Most people imagine that spacecraft stay in space because there is no gravity. But that's actually a myth. Gravity is still very strong hundreds of kilometers above Earth. In fact, the International Space Station is constantly being pulled toward our planet. So why doesn't it fall? The answer is simple. It is falling. Just not in the way most people imagine. Think about throwing a ball. The harder you throw it, the farther it travels before hitting the ground. Now imagine throwing it so fast that, as it falls, the Earth curves away beneath it at exactly the same rate. Instead of crashing into the ground, it keeps falling around the Earth. That's an orbit. A spacecraft must travel at an incredible speed, about 28,000 kilometers per hour in low Earth orbit. At that speed, gravity keeps pulling it inward, but its forward motion keeps it continually missing the ground. It's an endless balance between speed and gravity. This is why reaching space isn't enough. A spacecraft must also reach the right speed. Without enough speed, it simply falls back to Earth. With too much speed, it could escape Earth's gravity entirely. Finding that perfect balance is one of the greatest achievements in space engineering. Reaching orbit is only the beginning. Space is one of the harshest environments imaginable. There is no breathable air, no atmospheric pressure. Temperatures can swing from scorching sunlight to freezing darkness. Tiny pieces of space debris travel faster than bullets. Even a small fragment can seriously damage a spacecraft. Engineers protect spacecraft with strong yet lightweight materials, insulation, shielding, and carefully designed systems that keep astronauts and equipment safe. Power often comes from large solar panels that convert sunlight into electricity. Computers constantly monitor every system, making tiny adjustments to keep the spacecraft stable and pointed in the right direction. Eventually, every mission must come home. Returning to Earth is one of the most dangerous parts of spacecraft enters the atmosphere. It collides with air at tremendous speed. This creates extreme heat around the vehicle. To survive, spacecraft use special heat shields that absorb and safely dissipate this energy. Without them, the intense heat would destroy the spacecraft before it reached the ground. From liftoff to orbit, and finally back home, every step depends on careful planning, remarkable engineering, and the laws of physics. The next time you watch a giant rocket rise into the sky, you'll know you're witnessing far more than a spectacular launch. You're seeing thousands of years of human curiosity transformed into one incredible machine. Every roaring engine, every separating stage, every carefully calculated maneuver, and every orbit around Earth is made possible by science, engineering, teamwork, and decades of innovation. The journey to space isn't about defeating the laws of nature. It's about understanding them and using them wisely. And perhaps that's the greatest lesson of all. The universe may seem impossibly vast, but every mission begins with one question. How can we make the impossible possible? If you enjoyed discovering the science behind today's mystery, subscribe to Beyond How and join us as we explore the fascinating engineering, technology, and natural wonders that shape our world. Because every great discovery begins with one simple question: how?